As Russia prepared to return to the moon after nearly half a century of absence, the original project was named Luna Glob, a term that could be loosely understood as lunar sphere. Yet, it was precisely this name that left Zelliny, the scientific director of the Space Research Institute under the Russian Academy of Sciences, dissatisfied. He believed it failed to reflect the legacy once built by the Soviet Union, and so the name Luna 25 was ultimately chosen as a direct continuation of the legendary Luna mission series, the same program that last achieved a successful moon landing in 1976. And yet, when looking back at the entire story, it's hard not to feel that there was something quietly haunting about the abandoned name, like a silent omen no one wanted to acknowledge. Because now, with the outcome already clear, as the name Lunar Sphere seems to mirror the spacecraft's fate with unsettling accuracy. A complete journey that ended in a cold, silent stillness on the surface of the moon. And that is where today's story begins. The mission of Luna 25, Russia's first attempt to return to the moon since 1976, a nation that once led the space race, only to stumble right at the edge of history. What really went wrong? Although much of today's modern content tends to focus on missions led by NASA or ESA, looking back at history, it was the Soviet space program that once stood as a force the entire world had to reckon with. In 1957, the successful launch of Sputnik 1, the first artificial satellite in human history, officially ignited the space race between superpowers. And for a long stretch of time afterward, the Soviet Union continued to carve its name into unprecedented milestones. In 1961, Yuri Gagarin became the first human to travel into space. In 1963, Valentina Tereshkova became the first woman to reach orbit. They carried out the first multi-crew missions, sent the first living organisms beyond Earth, and kept pushing the boundaries as Luna probes successively flew by, impacted, and entered orbit around the moon, even returning the first images of its far side, something humanity had never seen before. By 1965, Alexei Leonov performed the first spacewalk in history, and not long after that, the Soviet Union further solidified its position with Salyut 1, the first space station ever to exist in orbit beyond Earth. And in the eyes of the world at the time, and especially from the perspective of Soviet leadership, everything seemed to be tilting in their favor. They were not just participating in the race, they were leading it. But behind those seemingly brilliant achievements, the reality was far more unforgiving. The Soviet space program also paid a price in tragedies that could not be publicly acknowledged at the time. In 1967, cosmonaut Vladimir Komarov was killed during the Soyuz 1 mission when the landing module's parachute system failed and could not deploy during re-entry to Earth. Just a few years later, in 1971, the three crew members of Soyuz 11, Georgy Dobrovolsky, Viktor Patsayev, and Vladislav Volkov, became the only humans in history to die directly in space after their capsule lost pressure as they departed from the Salyut 1 space station. Yet these losses revealed the true cost of being ahead in a field where nothing had precedent. And it didn't stop there. Numerous failed launches also took place in silence. In the context of the Cold War, when national image carried strategic weight, the Soviet Union often chose not to disclose unsuccessful missions, especially those aimed at the moon. Rockets that failed to leave the atmosphere were simply treated as if they had never existed in official statements. As a result, the picture the world saw at the time was only the surface. Behind it was a program filled with experimentation, errors and unacknowledged failures, a reality that only began to emerge years later, when classified documents were finally declassified. In 1969, the United States marked an irreversible milestone when Neil Armstrong became the first person to set foot on the surface of the Moon during the Apollo 11 mission. It was not just a scientific victory, but the pinnacle of an era defined by intense rivalry between two superpowers. Yet, it was also after that very moment in history that the momentum of the race seemed to begin fading. By the mid-1970s, both the United States and the Soviet Union gradually shifted their priorities toward other goals in space, rather than continuing to pursue crewed moon landings. For the Soviet Union, this carried a deeper meaning. Their cosmonauts had never truly set foot on the Moon, and the plans to send humans there were ultimately abandoned. The reasons were complex, and ranging from technical challenges and repeated failures in developing the heavy-lift N-1 rocket to the enormous costs the program demanded. But above all, there remained a strategic question. When your rival has already arrived first and claimed the most symbolic moment of all, does following behind still hold any meaning worth the price? However, as the 21st century began, especially after the collapse of the Soviet Union in 1991, a renewed wave of interest in the Moon gradually emerged. What was once seen as a completed objective was now being viewed from an entirely different perspective. Scientists began to see the Moon not as a final destination, but as a stepping stone for deeper journeys, particularly missions aimed at sending humans to Mars. Decades of research, including data from modern orbital spacecraft, that have revealed signs of water ice existing at the lunar poles, especially within regions that remain in permanent shadow, never touched by sunlight. This resource, if harnessed, could be split into oxygen for breathing and hydrogen for rocket fuel, effectively turning the Moon into a strategic transit hub for deep space exploration. At the same time, its low-gravity environment makes launching spacecraft far more energy efficient compared to Earth. Beyond science, the potential for resources has also begun to draw the attention of the private sector, opening up discussions about extraction and long-term human presence on the lunar surface. And alongside all of these factors, there remain countless unanswered scientific questions about how the Moon was formed, about the collision history of the solar system, and about the cycles that have quietly shaped Earth over billions of years. It wasn't just Russia. The United States quickly re-entered the game as well. In 2005, NASA officially launched the Constellation program with an ambitious goal: to return humans to the Moon after decades of interruption. But this time, the stage was no longer defined by a rivalry between two superpowers. Nations that had once stood on the sidelines began stepping in. India, through the Indian Space Research Organization, ESRO, initiated the Chandrayaan program in the early 2000s, signaling a clear ambition to explore the Moon. Across many governments, a shared perspective was beginning to take shape. This was no longer a symbolic choice, but a strategic move. Not participating could mean being left behind in an emerging competition over technology and resources. As former ESRO chairman Krishnaswamy Kasturirangan once emphasized, the question was no longer whether a nation had the resources to pursue such efforts, but whether it could afford to stay out of it. In that context, Russia had no intention of stepping back. As early as the mid-1990s, when the country was still navigating the aftermath of the Soviet Union's collapse, scientists like Mikhail Marov and Eric Galimov had already proposed a new lunar exploration program for Roscosmos. The project, initially named Luna Glob, was envisioned as a complex system consisting of multiple components, from penetrators designed for seismic studies to orbital spacecraft and even a lander. It was a clear sign that despite the challenges, Russia had begun preparing for its return much earlier than many might have expected. However, those early ambitions quickly collided with a far harsher reality. The Luna Glob project failed to secure the level of political backing needed to stay on track, especially at a time when Russia was struggling through severe economic instability. The financial crisis of 1998 saw the ruble lose more than two-thirds of its value in just a matter of weeks, triggering widespread cuts and delays across numerous scientific and technological programs. The lunar exploration effort was no exception. A series of setbacks gradually forced the original plan to shrink. Complex components such as seismic penetrators and an orbital spacecraft were systematically removed, leaving behind a far more simplified version focused primarily on a lander as a cost-effective solution. The ambition was still there, but it had to adapt to limited resources. By 2005, Russia's total budget for its space industry stood at around 20 billion rubles, equivalent to roughly $700 million at the time, a modest figure when compared to the more than $15 billion invested by the United States during the same period. Facing limited resources, one path Russia chose was to seek international cooperation. In 2007, they reached an agreement with India to jointly develop the Chandrayaan-2 mission, in which Russia would be responsible for building the lander, while India would handle the orbiter and other components. Under the original plan, this was meant to be a collaborative mission, where Luna 25 essentially served as the landing segment of the overall project. But over time, financial and technical difficulties began to surface. The development of Russia's lander was repeatedly delayed and ultimately failed to meet the planned launch window in 2013. Confronted with the risk of indefinite postponement, India made a decisive move to withdraw from the partnership and fully develop its own landing system. Chandrayaan-2 subsequently became an entirely independent mission for India, while Russia was forced back onto a solitary path, continuing Luna 25 as a standalone project, a turning point that revealed not only a shortage of resources, but also the gradual loss of critical opportunities for strategic collaboration. In 2019, India's Chandrayaan-2 mission fell short of its objective when the Vikram lander lost contact during its descent and was later confirmed to have crashed onto the lunar surface. But that failure didn't stop them. Within just a few years, ISRO rapidly developed Chandrayaan-3 as a corrective effort, focusing entirely on achieving a safe landing. That move, almost unintentionally, placed India and Russia into a new kind of confrontation, shifting from cooperation to direct competition. Both were aiming for the same destination, the region near the Moon's south pole, where data from multiple missions, including the earlier Chandrayaan-1, had revealed signs of water ice through spectroscopic measurements. This was not just a scientific discovery, but a key to long-term exploration plans. So when Russia's Luna 25 and India's Chandrayaan-3 were both being prepared for launch in 2023, a new race began to take shape. The goal was no longer simply to reach the Moon, but to become the first nation to successfully land in the South Polar region, an area considered a potential resource reservoir and a strategic stepping stone for humanity's future in space. But just as everything seemed ready for a long-awaited return, Russia found itself facing an entirely new variable. In 2022, the conflict in Ukraine triggered an unprecedented wave of sanctions from Western nations. These measures didn't just strain the economy, they struck directly at the high-tech sector, as Russia's access to advanced microchips and critical electronic components became severely restricted. These were, after all, essential elements not only for military systems but also for space programs. At the same time, many international partners, including European organizations, began to withdraw from collaborations with Roscosmos. In a global technological ecosystem where supply chains are deeply interconnected, such isolation meant Russia was now forced to develop or replace technologies it had once been able to source with relative ease. Meanwhile, India continued moving forward. Chandrayaan-3 was successfully launched on July 14, 2023, following a fuel-efficient trajectory that gradually raised its orbit before heading toward the Moon. A journey lasting over a month, with a planned landing on August 23, 2023. Russia, however, had a different approach. With the Soyuz 2.1B rocket and the frigate upper stage, they had the capability to reach the Moon on a faster trajectory, significantly reducing travel time. That meant if everything went according to plan, Luna 25 could very well arrive ahead of Chandrayaan-3. And in a race where every single day carried weight, the advantage of time could mean everything. By the final stages of preparation, Luna 25 had already gone through a prolonged silsila of delays, slipping from its original plan in 2021 to 2022, and ultimately not reaching readiness until 2023. One of the most significant issues lay in its inertial navigation system, where sensors within the unit failed to pass quality tests. As technological restrictions continued to tighten, reliance on foreign components became an increasingly visible weakness, forcing Russian engineers to develop a domestic alternative, and integrated into a new control system known as BIUSL. After multiple adjustments, the mission was officially approved for launch in August 2023. Luna 25 carried 8 scientific instruments developed by Russia, including spectrometers to analyze material composition, surface observation equipment, and sensors designed to study the dust environment and micrometeorites. If the landing proved successful, the spacecraft was expected to operate for about 1 year, enduring some of the harshest conditions on the Moon, from the deep cold of the prolonged lunar night to intense radiation during the day. The mission was launched aboard a Soyuz 2.1B rocket, paired with the frigate upper stage from the Vostochny Cosmodrome in the Amur region. With its more direct trajectory, Luna 25 was calculated to reach the Moon and prepare for landing before August 21st, 2023, creating a time advantage over India's Chandrayaan-3, which was scheduled to land on August 23rd. In that moment, everything seemed to be tilting in Russia's favor. Luna 25 was successfully launched from the Vostochny Cosmodrome on August 11, 2023, and just 5 days later, on August 16th, the spacecraft entered lunar orbit as planned. The initial signals were highly encouraging. Systems were operating steadily. Communication with Earth remained stable, and the probe even transmitted surface images, including areas near the Zeeman crater in the South Polar region. Everything pointed to a mission on the right track. As it moved into the landing preparation phase, Russian engineers exercised extreme caution. The region near the moon's south pole is known for its rugged terrain, steep slopes, and prolonged darkness, conditions where even the slightest miscalculation can lead to catastrophic consequences. And then, at the most critical moment, everything began to slip out of control. On August 19, 2023, contact with Luna 25 was suddenly lost during a maneuver to transition from a circular orbit to a pre-landing trajectory. According to data released afterward, the onboard control system encountered an issue while executing a trajectory correction command. One of the engines fired longer than intended, lasting about 127 seconds instead of the planned 84, causing the spacecraft's orbit to shift beyond its intended parameters. By August 19, 2023, nearly all hope had faded. After the failed orbital correction maneuver, Luna 25 fell into a decaying orbit and plunged toward the moon's surface at a velocity beyond any possibility of control. From Earth, Roscosmos engineers were left with virtually no options for intervention. Communication was completely lost, and the spacecraft continued its final descent in absolute silence. There were no cameras to capture the moment of impact, but the outcome was not difficult to imagine. Accelerated by the moon's gravity, the probe struck the surface at high speed, bringing the mission to an end just days after entering orbit. What had been expected to last nearly a year was over almost instantly. In the aftermath, NASA's Lunar Reconnaissance Orbiter passed over the area and identified a newly formed impact site. The crater was located on the inner rim of Ponte Coulangi, and measuring about 10 meters in diameter and lying nearly 248 miles away from the originally planned landing site, the final trace left behind by Luna 25 on the surface of the moon. Russia entered this mission with a clear objective: to prove that it still remained a formidable force in the modern space race. But Luna 25 was not just facing ordinary technical challenges. Geopolitical tensions had pushed the program into operating under far more difficult conditions. Sanctions disrupted critical technology supply chains, forcing Russia to replace certain key components with domestic alternatives. Even so, according to the official conclusions released after the accident, the direct cause of the failure was not confirmed to be related to component quality, but rather to a malfunction within the control system during the orbital correction maneuver, a small deviation with decisive consequences. At the same time, the pressure to complete the mission amid an increasingly visible competition with India cannot be overlooked. Luna 25 was designed to reach the moon faster, with the potential to arrive several days ahead of Chandrayaan-3. And in that detail, it echoes a moment from history. In 1969, the Soviet Luna 15 mission also crashed onto the moon's surface just hours before the United States Apollo 11 carried out its historic landing. Luna 15 at the time was designed with a very specific objective: to land, collect samples from the lunar surface, and return them to Earth, an effort running in parallel with the United States Apollo 11 mission. Although there were no humans on board, and if the American side had failed, the Soviet Union completing its mission in time could still have been seen as a symbolic victory. This was not just about science, but about prestige and influence during the Cold War. The Soviet Union wasn't simply aiming to reach the moon. They wanted to be first, or at the very least, not allow their rival to claim that defining moment alone. But when everything is driven by the pressure to outpace a competitor, the time allocated for testing, refinement, and safety is often compressed. And that is exactly what increases the risk of critical errors. Luna 15 did not complete its mission, and more than half a century later, Luna 25 seemed to echo a familiar pattern. The final outcome did not reflect the original ambition. Instead of reinforcing Russia's position in space exploration, the failure exposed the limitations of a program operating under restricted international cooperation and mounting competitive pressure. Had scientific collaboration channels remained intact, especially with European partners, the story might have ended very differently. In many ways, this feels more like a tragedy than a simple failure. A mission that had been anticipated for years came to an end in just a matter of days. But its true value may lie in what humanity takes away from it afterward. As we reach further into deep space, it becomes increasingly clear that no single nation can go it alone. Luna 25 may not just be a failure, it may be a lesson if it is understood the right way. History has shown that when ambition is driven by competitive pressure, mistakes are almost inevitable. And perhaps, in the end, yet what matters most is not who gets there first, but how far we can go together. Thank you to everyone who shares a passion for space for taking the time to listen to today's story, a documentary about space and the moon that is not just about a mission, but about the journey of human ambition, missteps, and hope. If you found value in this video, don't forget to share it so more people can explore it. Leave a comment with your thoughts and subscribe to the channel so you don't miss what comes next. Even a simple like is a way to keep stories like this going. Goodbye for now, and I'll see you in the journeys ahead.